right, so we're going to verify this identity. Cosine of x over 1 minus sine of x is supposed to equal 1 plus sine of x over cosine of x. All right? So let's start with the more complicated side. Well, it's about half a loaf of one and the other, so I'm just going to start with the left-hand side because they're both about equally complicated. It doesn't really matter which one. In fact, what I think I'll do is I will start with the left-hand side and finish this out, and then we'll go back and say, well, what if you had started with the right-hand side? What would that look like? And show that it doesn't really matter which way you go. You pick one and go with it. So let's suppose we think this is the more complicated side. So we're going to start with cosine of x over 1 minus sine of x. Since I'm going to do this twice, I might want to be a little conservative with my space here. All right, change alpha, no, that's not going to help because there already are in terms of sine and cosine. There are no identities in play. There is no Pythagoras here. This is not sine squared. Well, this is what we're looking for. We're not there yet. Conjugate, look, we have 1 minus sine of x. Put the binomial in parentheses. What we're going to do is this. Take this expression. Here's the technique. I'm going to take this expression and multiply it by 1. If you take this expression and multiply it by 1, you have not changed the value of the expression. What you may not do this. You may not do this. I've not multiplied by 1, I've multiplied by something different than 1, and now what I've started with is not going to equal what we end up with. In order to equal something, what you must do is take this expression in this scenario, you must multiply it by something over itself. And the itself you choose is the conjugate. It's just like back in the day in algebra when you had to rationalize those god-awful, improper, irrational fractions. 1 plus sine of x, 1 plus sine of x. You multiply the numerator and the denominator by the same conjugate. How do you know which conjugate to pick? Look at the one you have and choose the appropriate. This is minus, so you want plus. Since you want plus here, you want top and bottom to be the same thing. All right? So, what is this equal to? Here's the technique. This is the procedure. This is the advice. Multiply the conjugates. Whenever you multiply by conjugate, whenever you do this technique, here's the procedure. This is just the technique. You need to know how to use it. Yes, you multiply the conjugates. That's the whole point. So outside 1 squared is 1 minus sine squared. But the non-conjugates, typically you don't multiply. The non-conjugate portion, you typically do not multiply. So the non-conjugate portion, don't even distribute. Don't just write it as that. Don't even distribute. Don't even distribute it. Now, leave this numerator alone. Watch for identities. Does that smell familiar? Do you remember Pythagoras? Remember Pythagoras? The fundamental Pythagoras says sine squared plus cosine squared is equal to 1. But if you subtract the sine squared to the, remember we had alternate forms for that basic identity? That's why you need to know them. That's why they need to be at your fingertips. So that when you need this, you actually have it. You don't need to go rummaging around. This is given, or this is known. Subtract this to the other side of the equation. And what do you generate? You generate 1 minus sine squared. But what is that equal to? That's equal to cosine squared. 1 minus sine squared is equal to cosine squared. If you see Pythagoras, employ Pythagoras. Watch for identities. That's a standard technique. Always be on the lookout for Pythagoras and use the substitution from Pythagoras. And now, do some algebra. We have a cosine factor in the numerator, cosine squared factors in denominator. This cosine cancels with one of these. Remember what this really means? This means cosine of x quantity squared. So this cosine cancels with one of these cosines, right? So can we write that? Right? Or think about it this way. This cosine cancels here and leaves one of the cosines remaining. So what do we have? What do we have out of all that? The numerator is 1 plus sine of x. What do we have left from the denominator? What's left is cosine of x. Now the question is, what do we do with this? Well, keep an eye on the target. What do you do with this? Nothing, because you're done. So this is the side you were trying to achieve. We started with the left-hand side and argued until we got the right-hand side. So that's our valid proof, and we verified the identity. All right? The next video, what I'm going to do is I'll go back to this without some of the explanation. I will start with the right-hand side and show how to generate the left-hand side. Maybe before you watch that video, you should try it yourself. Try starting with the right-hand side, going through in a very parallel structure, and see if you can generate the left-hand side. And then whether you get it or not, then you can watch the next video, and that'll talk about my solution for that and see if we can match things up.